Hello, I am back with session 6. Session 6 is pretty fun, but we do need to go over a couple of mathematical terms to set you up for success with that. So we are going to learn today about drawing to scale. Okay, now I know you've heard of scale before because you've studied maps before and you've used maps in investigations, and so that probably sounds pretty familiar. It means that rather than just kind of willy-nilly being like, well, if my playground's this big, then my bench will be this big, and just kind of making it up and eyeballing it, it means you're really going to actually be measuring it out. So when something's drawn to scale, it's really measured and it really is very specific. So we're going to be using cross multiplication to figure out some unknown things in scale drawings. Okay, so my scale for this is going to be 1 inch equals 3 feet. So that means if I drew something that's 2 inches long, right? This is 2 inches. If 1 inch is 3 feet, then 2 inches is 6 feet, right? So I can't really draw something that's 6 feet long. That would be its actual size. Its scale size is 2 inches long. So now there's going to be some sort of puzzles that you have to investigate where you figure out scale size versus actual size. So if I tell you that we're always going to put scale over actual. So if I tell you that, my scale is that 1 inch equals 3 feet, then my scale over my actual is going to be my known, right? I know that. I know that 1 inch equals 3 feet. Don't think of it so much as a fraction, which is how I know you're used to looking at this, and more as a ratio. So 1 inch is to 3 feet, as now I'm going to say to you, well, I want to draw something that's 12 feet long. How many inches do I need to make it? How are you going to figure that out? Well, 1 inch is to 3 feet, as unknown is to 12 feet, right? So we can use cross multiplication. We can say, well, 12 times 1 is 12. 3 times what equals 12? 3, 6, 9, 12. Right, 4. So that would mean that if something was 12 feet long, that I would need to make it 4 inches long in my drawing. So we're going to set it up. Scale over actual equals scale over actual, and one of these might be your unknown, depending on what you're working with. We're going to do another example in just a second. So here I have that 1 inch equals 3 feet, and here I know my actual, and here I know my drawn, and then my unknowns are over here. So you might actually be able to do this in your head and say, well, 3 feet equals 1 inch, right? For that first one, that's kind of a given. But to show you what that looks like, this equals that here. So the drawn is going to be 1 inch. Well, now if my drawn is 4 inches, what do I need to do to get back over to this side of the table? What's my rule for my ratio table? So before I use cross multiplication, setting it up in a ratio table is another strategy. What's my rule to get from this side to this side? Every 1 inch is 3 feet, so I need to multiply by 3. So 4 times 3 is 12. So my actual is 12. And that will work going both ways. So let's just say that I have, it's 15 feet, and I want to know how many inches. Well, if it's times 3 going this way on the table, it's going to be divided by 3 going this way on the table. So now I can also find out that 15 divided by 3 equals 5. And I can fill in my ratio table that way. So you can use cross multiplication. You can kind of rewind to go back to that part if you like that. Or you can use a ratio table, which is what it's asking you to do on slide 14. So you can hop over to slide 14, work on that a little bit, let me know how you're doing. You need to have an understanding of drawing to scale because your next step is actually going to be to draw your playground to scale. So you need to decide what your scale is going to be, and you need to be familiar working with these scale numbers. So make sure you go in there and practice, and make sure you come check in if you have any questions. Bye.